When you're developing a new product, one of the biggest decisions you will make is choosing the right material. It may sound simple. Metal, plastic, maybe a composite, but the single choice can completely change how your product gets made. Material choice doesn't just affect strength or durability. It shapes the manufacturing process itself. The moment you pick a material, you are also narrowing on the tools, machines, and tolerances that make sense for it. Every process has its own rules. Injection molding expects drafts and balance wall thickness. Casting requires allowance for shrinkage. Sheet metal forming has bend limits. Extrusion likes continuous profile shape. Machining wants sensible tool access. Pick one path, and the design needs to respect those constraints. Otherwise, you invite more rework. Beyond manufacturability, the right material depends on the application, use cases, environment, and often target price range. Those factors define what matters most: weight, stiffness, corrosion resistance, surface finishes, lifespan, sustainability, and that priority list points you to a short list of viable material and processes. Sometimes swapping materials brings real benefits. Plastics can replace metals to cut weight and cost or simplify corrosion concerns. But those gains aren't free. The design usually needs to change to suit the process, and you will validate the performance with the right mechanical test to make sure the product still does its job. And it's not just the type of materials, the grade matters. Different grade of steel or certain plastics can dramatically affect the process parameters, surface finish, cost, and the product long-term durability. Ideally, you select the material family early, but the exact grade often gets finalized during the FM phase, once you have aligned with suppliers, tooling, and realistic process windows. That's why material selection isn't one-off tick box. It's an ongoing conversation between design and manufacturing. When the material grade, geometry, and process are aligned, you get fewer surprises, more consistent quality, and cleaner path to scale. Good DFM is about that alignment. Choosing materials that, with the real world in mind, how they will be made, assembled, finished, and used, and you will save time, reduce cost, and build something that lasts. Next episode, we will wrap up this series by bridging between prototypes and full-scale production, where the FM really proves its value. For now, check out the blog post, a link to this video for more information, and how material decisions can make or break a design. Till then, thank you. See you.